right, this is a reteach over transformations. So first of all, if there's any announcements or anything during this video, I'm really sorry. I'm doing it after school, but I still wanted to provide it for y'all. All right, so translations. It starts with a T, so I always think of it as it looks like a plus sign. So this is going to be my one where I'm going to be adding or subtracting. So if we're going up and down, that is my y-axis. So up and down affects my y coordinate by adding or subtracting a number to it. Versus if I'm going left to right makes my x-axis, and so it's going to add or subtract to my x value. Most translations are going to give you both. They're going to give you up and a down and a left or a right, but now you know which one affects which. Reflections are flips. All right, so we're going to be flipping one of our coordinates. It gets to stay the same, and my y is going to flip to its opposite. And the reverse happens for my y. My y stays the same, and my x becomes its opposite. We're going to skip rotations for just 1 second. And we're going to look at dilations. A couple things about dilations is we need to know that K is our scale factor. And we do it as K times X and K times Y. 3 things about dilation. When our scale factor is greater than 1, this is an enlarge, and it gets big. Versus when my K is less than 1, this is a reduction or reduce, and it gets smaller. Now, unfortunately, I don't have any little tricks or tips really to help with those. You're just going to have to know those facts. All right, on to rotation. Rotation is a turn, and so we always start off with our coordinate as XY. And when we do a 360 turn, so I have a triangle here I can show you. So when I do a 360 turn, it's going to end up right back where it started. Oh, somehow drew on this. But it's going to end up right back where we started. So we know our 360 needs to end with coordinates XY. Clockwise goes the direction of a clock. And so the best way to learn these, you can just memorize them, but I have a little trick that helps some people. So I'm going from left to right, so I'm going to go left, and I'm going to switch this, flip it to its opposite, and bring down my Y. And I'm going to keep doing that. I'm going to slide it, flip it, bring down my X. Slide it, flip it, bring down my Y. Slide it, flip it, bring down my X. And you can see I ended where I started. Also, you might see that your 180, all it does is it keeps your X and Y where they were, but it's now the reverse side or the back side of it, if you think of it that way. It's the opposite of it. Now, counterclockwise is done the same way, except we're going to go the other way. So we're going to start with our Y's this time. So I'm going to slide it, flip it, bring down my X. Slide it, flip it, bring down my Y. Slide it, flip it, bring down my X. Slide it, flip it, bring down my Y. Again, I ended where I started, but also these are reverses of each other. So we both start XY. My 270 and my 90 match. My 180s are the same. My 90 and my 270 match. And my 360. This is guaranteed on your test, so be sure you know it. Preserving congruence means I'm preserving the size. All right, and so we have, if I slide this, translate it, it keeps the same size. So translation preserves congruence. If I turn it, it still keeps its same size. So rotation preserves it. If I reflect it, it kept its same size. But if I dilate it, which in this case means it got smaller, it did not keep its same size, so it did not preserve congruence. When we're looking at orientation, that means my vertices are going to be in the same. So if I'm going clockwise, we're going A, B, C. If I translate it, it's still going A, B, C. So translation preserves orientation. If I rotate it, even if it's turned, it's still going A, B, C. It's still going clockwise, so rotation. If I reflect it, so I flip it, it's now going A, C, B. So it did not preserve its orientation. And dilation, making it smaller, it's still rotation. All right, let's look at, I'm going through these kind of quickly so this video is not too long. So now we're going to look at translating, doing some rules. So this is going to be adding and subtracting. So if I'm going to the right, that is my x-axis. And I'm going to be adding to my x because going to the right is addition. Going down is my y-axis, and going down is subtraction. So what I'm going to do is I'm going to take this x-coordinate and I'm going to add 3 to it. I'm going to take this y-coordinate and I'll subtract 5 from it. I'm going to do that on repeat, add 3 to my x, take my y and subtract 5, and I'm just going to keep on doing that. Until I get new coordinates. Now what I want you to do is I want you to pause this video and I want you to go ahead and try to find the rule and do the coordinates for this one. Push play when you're ready to see the answers. Alright, so you should have gone ahead and tried this. So going to the left means I'm going to affect my x, and going to the left is subtraction. Going up affects my y, so I'm going to add to it. So my new coordinates should be 4, 4, negative 7, 1, 5, 2, and 0, 3. Because I subtracted 2 from each of my x's, and I added 3 to each of my y's. Alright, so let's look at the back side, and let's look at some reflections. If I'm reflecting over the y-axis, my y stays the same while my x is its opposite. So my x, which was 3, will now be its opposite, which is negative 3. My y stays the same. My negative 2 becomes 2. My y becomes negative 5, stays negative 5. My 6 becomes a negative 6 because I want its opposite, and y stays the same. X, the opposite of 0, is just 0, and my y stays the same. So what I want you to do is pause this video and try the next reflection, and when you're done, unpause the video so you can check your answers. Alright, so you should have already paused the video and gone ahead and tried this. Some of you might not do that. You might just skip ahead. So let's start with what our rule would be here. If we have a reflection across the x, our x will stay the same. Our y will be its opposite. So our coordinates should be 6, negative 1, negative 5, 2, 7, 1, and 2, 0. Alright, let's look at some rotations. Okay, rotation. So I could flip back to the front and look at my table and find out what my rotation would be. So if it's counterclockwise, I come over here, 90 would be negative yx. Okay, I could also rework it. I could say x, y. This is going counterclockwise. So I'm going to slide, flip, bring down. So we have negative yx. And this is where it gets a little challenging. So I'm going to be looking at my y first. I'm going to cover up my x. So y is going to go first. So that's a 4, but it's now going to be its opposite, so -4. And my x will stay the same. My y is going to flip, do its opposite. My x will stay the same. My y is going to do its opposite. My x will stay the same. My y will do its opposite, and the x will stay the same. All right, if we do 180, again, we could look at our chart, or this first one was a 90. So if we go one more, it's going to be a 180. So slide it, flip it, bring it on down. So -x, -y. So notice my x and y are staying in the same order. So they're staying as x and y, but they're now the opposite. So the opposite, or the inverse, of 6 is -6, and then -1. Opposite of -5 is 5. Opposite of y is 2. Opposite of 7 is -7. Opposite of -1 is 1. Opposite of 2 is -2. Opposite of 0 is 0. All right, let's look at 90-degree clockwise. Again, I could go look at that chart if I wanted to, or I can do it myself. So if I have x, y, this time I'm going clockwise, so I'm going to slide this way. Slide, flip, keep. So of y, -x. Notice my x and y are not in the same position as they were before, so I'm going to be flipping that. So we have my y, which is 4. It's going to stay as a 4. My x will be its opposite, -3. Y will stay the same. My x will be its opposite. Y will stay the same. And because x is the negative version, it's going to be its opposite. Y will stay the same, and x will be its opposite. Now notice every single coordinate has a parenthesis and it has a comma. You will be expected to use parentheses and comma every time. All right, for the blank one, I left it blank because in class I didn't know if we have time, but we did a rotated 270 degrees clockwise. So I want you to pause the video and I want you to see if you can come up with the rule and the new coordinates and push play once you've done it. Now go ahead and try it. Alright, so you should have found out the rule was -yx, which means my y is going to be its opposite. My x will stay the same. My y will be the opposite, and x will stay the same. My y will be the opposite. My x will stay the same. My y will be the opposite. My x will stay the same. Oh, sorry, you can't even see that very well. All right, now we're going to look at dilation. Dilation. So dilation is all right. So we're going to write that it is multiplication, multiply. And our rule here, since our scale factor is 1/3, is going to be 1/3 x, 1/3 y. All right, so we're going to multiply this coordinate by 1/3. 3 times 1/3 is 1. 3 times 1/3 is 1. -6 times 1/3 is -2. -3 times 1/3 is -1. 6 times 1/3 is 2. -9 times 1/3 is -3. 0 times 1/3 is 0. 12 times 1/3 is 4. All right, and then you're going to do, I want you to try this one on your own. So you're going to pause, write the rule, and see if you get the coordinates, and unpause it once you have your answer. All right, so you should have done it by now. So you should have 2x, 2y. So I'm going to multiply these all by 2. So 12, 2. negative 10,